What is an Armstrong number? So Armstrong number is that number, if you take the individual digits of that number, cube them and then add them, you should get the original number. For example, take this 153. Take the separate number, like that means separate digits, individual digits of this number. 1, cube it. 5, cube it. 3, cube it. That is, multiply individual number 3 times, like 5 into 5 into 5, 3 into 3 into 3, 1 into 1 into 1. Add them. When you add them, if you get the original number, that is 153, that will be an Armstrong number. Say 111. If I cube it, it will be 1 cube plus 1 cube plus 1 cube. So it will be 1 plus 1 plus 1, that is 3. So 111, which is equal to 3, and they are not equal. 111 is not an Armstrong number. Similarly, 371, cube 3, cube 7, cube 1, it will be, and you add this, it will be equal to 371, which is the original number. That is why 371 is an Armstrong number. How to make the program of Armstrong number? First of all, I have this 153. I'll take an example, then explain. Now I want individual number. How to get the individual number? In any programming language, C, C++, Java, any language you take, the idea or the logic of taking the individual number is modulo. For example, if I divide 153 by 10, what do I get? 10, 15s are 150, you get 3. So you get this last number by dividing this 153 by 10. So if I take 153 and take modulo with 10, modulo gives you the remainder. So this is the remainder, so you get the individual number. I hope you got the idea. So this logic, n modulo 10, is exactly this. We are getting the individual number. Once this is done, then we have this as the, you can say the, this is the divisor. Once you divide it, you get this. This is the quotient, this is the divisor. So now 15 you have. How do you get this 15? When you divide 153 by 10, when you divide 153 by 10, you get 15. So in order to get the other number, because 3 has already been taken, now you have to deal with 15. So in order to take this 15, you have to divide it by 10. Now you are left with 10, with 15 again. Divide this again by 10. You get 10, ones are 10, and this is 5. So here you get the second number, this one. So this is the remainder, and as I told you, when you take 15 modulo 10, you will get 5. So other number, the last one was there, the penultimate one, the one you already got, and then this one is what? 15 divided by 10. So you get 1. And next time when you divide, this one is remaining. When you divide, you will get something in points, right? Some point value. And this, because this is an integer, you will get a 0. So this is the logic, n greater than 0. You will do it, you will take modulo and divide it. Modulo to get the individual numbers, that is this one, and divide it to get the other numbers, because this has to be scrapped. Once you have done with 153, now you need 15. Once you have taken this 5, you need only 1. So this is the division. And this n greater than 0 means once you reach 1, means you have already taken the 3 numbers, then you will get a 0, and this n has to be greater than 0. Otherwise you will not, means you have to run the loop till n is greater than 0, that you will not get here. So you get 3, 5, 1, and you just stop this loop. Now let us come to the program. The program is in C, but you can always use it in C++, etc. Java also. Only the printf, scanfs, and the taking the number and printing will change. Other logic remains the same. I'll discuss about this later. First, you will ask for the number. Printf, enter the number. When the number is being entered, you will take it in n. So this n is actually 153. You will scanf, and this n we have declared it as an integer. Now since we are actually working with 153, see, we are actually changing this number, original number. So we have to save this number somewhere, because we are going to check this sum, that is 1 cube, 5 cube, 3 cube addition with this original number. So we are just saving it in some temp variable. So this temp variable is doing nothing, just saving the number so that it can be checked or equated later. Now coming to this one, this n greater than 0, that is 153 greater than 0. You come here, you take the modulo, n modulo 10. So n modulo 10, 153 modulo 10. It is going to give you 3. So 3 will come at r. Now you are taking r cube. So this r is a variable again, just to have these 3, 5 and 1 which has been taken or which has been extracted through modulo operator. You have a r variable here. Now cube it and add it to the sum. What is this? Sum equal to sum plus r. This sum is equal to 0. Initially it is 0. You have already taken 3, so it will be 3 cube. So sum will have 3 cube. Now you need to scrap off this 3. Then you will take 153 divided by 10. And what do you get? See, you get 15. So now you have made this n as 15. So original number has been changed. Then you go back again. Since this 15 is greater than 0, you go again inside the loop. Now again n modulo 10, 15 modulo 10, that is you are going to get 5 here. Now sum was already having 3 cube. So now you will add 5 cube here. And the sum will have 3 cube plus 5 cube, because sum was already having 3 cube. 3 cube plus 5 cube. Now you want to scrap off this 3, this 5 also. 3 already done, 5. So you divide it by 10. So now only 1 is remaining. Now you go again back. Now 1 is greater than 0. Now you come here, n modulo 10, 1 modulo 10 will be 1. And sum is already having 3 cube plus 5 cube. So now you add 1 cube. So 1 cube will be added. Now you will again say n by 10, that is 1 by 10. So n will become 0, because this is an integer. You go back again and you see, oh, this is 0. 0 is not greater than 0. So you will not go inside the loop. So now this sum will have the value of 153. Because 1 cube plus 5 cube plus 3 cube is 153. And as you remember, we have already stored this temp previously. So this temp was already having 153. This sum was already 153. You check it and they are equal. This is an Armstrong number. Just assume that you have given 135 here. Same procedure. You take 5 first, 3 and then 1 cube them and you come here. This was 135 which you already stored. And now this will be 1 cube plus 3 cube plus 5 cube. So 1 plus 3 cube, 3 3 is 9, 9 3 is 27 and 5 125. 27 and 1. So 5 7, 5 and 6, 5 and 6 is 3, 1 and you get 5 3, 153. So 135, again a Armstrong number. Now you put 1 1 1, 1 1 1. Now 1 cube plus 1 cube plus 1 cube is 3. So 1 1 1 is not equal to 3. So this will not be printed, else will be printed not an Armstrong number. This is how the program will be written.